All right, let's get straight to it. This is a security briefing on the AI agent framework, OpenClaw. And look, forget all the hype you've heard about superintelligence for a minute. The real, immediate danger is much more boring and much more critical. It's exposed infrastructure. We're going to break down the architectural risks that make this tool a prime target right now.
So, as of early February 2026, our threat intel team found this number, 42,900. That's how many internet-exposed OpenClaw control panels were sitting out there in the open. This isn't some theoretical flaw. This is a live, global exposure of tens of thousands of privileged AI agents. And that number was going up every single hour. You might be asking, how does a problem get this big, this fast? Well, it comes down to a dangerously insecure default setting. Right out of the box, OpenClaw binds to 0.0.0.0. Now, for the non-network folks, that means it's listening on every network interface. Instead of just talking to your local machine, it's basically shouting its existence to the entire internet, creating a huge inviting attack surface. And get this, over a third of these were vulnerable to immediate remote code execution.
Okay, so we've got this massive exposure. Now let's dig into the attack itself. We're going to focus on the most critical vulnerability here, CVE 2026-2523, because it turns this widespread exposure into a direct line for total system compromise. There's a reason researchers are calling this a one-click RCE kill chain. An attacker can get full remote code execution with just a single click from the victim. And the whole thing is over in milliseconds. That's faster than anyone could possibly notice, let alone react to.
The attack itself is, well, it's brutally effective. It's a three-step process. First, the victim just clicks a specially crafted link. The OpenClaw UI, without doing any checks, immediately opens a connection to the attacker's server. In that handshake, it leaks the user's authentication token. And here's the pivot. This is the kill shot. The attacker grabs that token, uses it to connect back to the victim's local instance of the agent, turns off all the security sandboxes, and boom, they can run whatever commands they want. The victim's own browser becomes a bridge to attack them, completely bypassing the firewall.
Look, a patch can fix a single bug like that one, but it doesn't solve the much deeper problem. OpenClaw and agents like it represent a brand new kind of architectural risk because they combine three incredibly powerful abilities into one single unsandboxed process.
We call this the Lethal Trifecta. First, the agent has access to all your private data, files, emails, you name it. Second, it's constantly pulling in untrusted content from the web. And third, it has the authority to act on your behalf, send emails, run commands. When you smash those three things together without rigid security boundaries, the agent becomes what we call a confused deputy. It can be tricked into using its legitimate power for malicious purposes, because it simply can't tell the difference between your commands and an attacker's. This confused deputy problem is triggered by something called prompt injection. And you really need to understand this. This is the core fundamental vulnerability of all large language models. An attacker just hides a malicious instruction inside a piece of content, say a web page. When the agent reads that page to summarize it for you, it reads the hidden command and executes it as if it came directly from you.
This is why our entire security paradigm has to change. You see, traditional security is all about finding code-level bugs, things like SQL injection. We defend against those with firewalls, with web application firewalls, with code scanners. But prompt injection is totally different. It is a language-level flaw. It's part of how the LLM works. No firewall on Earth can detect a malicious command that's hidden in plain English. The threat isn't code, it's language. And the only way to defend against it is with structural isolation.
So you can't just patch this away. You have to build your architecture to defend against it from the ground up. So we've put together a 4-layer defense strategy that you can use to harden any AI agent deployment.
Layer 1 is isolation. You have to treat the AI agent as a completely untrusted process. Run it inside a hardened Docker container and make the file system read-only. That contains the blast radius. It means a compromised agent can't get to your sensitive host files like your SSH keys or your password manager. Layer 2 is identity. You have to start thinking about an AI agent as a new kind of privileged identity. Manage it with the same discipline you'd use for a human sysadmin. That means you get rid of static, long-lived auth tokens. You move to just-in-time access and short-lived credentials for any sensitive task.
Layer 3 is network controls. And let me be perfectly clear. This is non-negotiable. You never, ever expose the control panel to the public internet. Bind the service to localhost, and if you need remote access, use a private mesh network like Tailscale.
This makes your agent completely invisible to those internet-wide scans we saw earlier.
So that brings us to our final layer. Because the agent itself isn't the only risk, its ecosystem of third-party skills is a huge threat vector. A recent audit of the official ClawHub marketplace was, well, it was alarming. They found that a staggering 15% of all available skills were actively malicious, designed to do things like steal info and install backdoors.
So layer 4 is governance. You absolutely need a strict supply chain security policy for your agents. You have to audit where every single skill comes from. And honestly, with malware rates like that, you have to assume that third-party code is hostile until you can prove it's not. That means manually reviewing it before you give it any access to your system.
When you put all this together, it leads to a pretty clear and unavoidable recommendation for any organization that's looking at this technology. This is the choice you, as an architect, have to make.
Our primary recommendation is this. Do not run OpenClaw or any agent like it on any machine that has access to corporate credentials until all 4 layers of this hardening blueprint are fully implemented and active. The risk of credential theft and an attacker moving through your network is just too high to ignore.
So we'll leave you with this final thought. AI agents are a brand new class of privileged identity inside your network. They have all the permissions of a user, but none of the predictability of a human. The question isn't if you're going to adopt these tools. The question is your architecture ready to manage them?